So, let us move on to the question number 13. If integral of log of x plus root over 1 plus x square by root 1 plus x square dx is equal to G's composition f of x plus integration constant c, then the first option f of x is equal to log of x plus root over x square plus 1. Second option, f of x is equal to log of x plus root over x square plus 1 and g of x is equal to x square. Third option, f of x is equal to log of x plus root over x square plus 1 and g of x is equal to x square by 2. Fourth option, f of x is equal to x square by 2 and g of x is equal to log of x plus root over x square plus 1. Let us see how this can be done. Now, actually the derivative of log of x plus root over 1 plus x square is 1 by root 1 plus x square. So, it is appearing to be in the form of f of x into f dash of x. You put log of x plus root over 1 plus x square as t. Now, differentiating dt by dx is equal to 1 by x plus root over x square 1 plus x square. Now, the derivative of this, what do we get? 1 plus 2x by root over 1 plus x square, 2 cancels, and what do you have here? Turns out to be 1 by root 1 plus x square dt by dx. Now, transpose this dx term the other side and dx by root 1 plus x square is equal to dt. So, now this dx by root 1 plus x square can be replaced with dt. Now, it is turning into the form of t dt. And what is that? T square by 2 plus c. What is that? Log of x plus root over 1 plus x square the whole square by 2 plus c. So, it is clear from, I can say this is now, if g of x is equal to, g of x is x square by 2, f of x, the inner function is log of x plus x square root 1 plus x square. So, now if we take g of x to be this and f of x to be this, clearly g circle f of x will be this function. Therefore, the right option is option 3. Answer is third option. Let us move to the next question, question number 14. Integral of e power of x minus 1 plus x raised to the power e minus 1 divided by under root over e power x plus x power e dx. Now, let us see how this can be done. The options are, first option 2 by e into root over e power x plus x power e plus c. Second option 2 into root over e power x plus x power e plus c. Third option half of root over e power x plus x power e plus c. And fourth option 1 by e into root over e power x plus x power e plus c. See, let us see how this can be done. Generally, when you have a integrand in this form, the one which is appearing to be more complex is this part, which is involving the third part. So, we will put e power x plus x power e as some t. Put e power x plus x power e is t. Then when you are differentiating, so what do you get? dt is equal to e power x plus e into x power e minus 1 dx. We almost have that, barring we can rewrite this as, we can write this e power x as e into e power x minus 1. So, there is a e common throughout. So, what is it I have here? We have e power x minus 1 plus x power e minus 1 into dx. The t which we have common, we will take it the other side and dt by e. So, this e power x minus 1 plus x power e minus 1 dx, this portion can be replaced with dt by e. So, we have the integral to be 1 by e into dt by root t, and this is t power minus half integral of t power minus half dt plus c, that is 2 by root t 1 by e plus c. But what is t? That is 2 by e into root over e power x plus x power e plus c. Therefore, the right answer is in the option 1. Let us move to the next question, question number 15. Integral of sine 2x by 4 cos square x plus 9 sin square x dx is equal to, first option 1 by 13 log of cosecant 4 cos square x plus 9 sin square x plus c, and second option 1 by 12 into log of 12 tan square x plus 9 plus c, third option 1 by 5 into log of 4 cos square x plus 9 sin square x plus c, and fourth option log of 4 cos square x plus 9 sin square x plus c. Now, if you see in most of the options here, we observe that it is involving log of 4 cos square x plus 9 sin square x. So, then let us contemplate on this. What if we substitute 4 cos square x plus 9 sin square x as t? Let us go for that. Put 4 cos square x plus 9 sin square x as t. Then on differentiation, what do we get? dt. Here we have, what is the derivative of cos square x? Minus 2 cos x sin x. That makes it 4 into minus 4 into sin 2x. Whereas the derivative of sin square x is sin 2x. So, that makes it 9 sin 2x dx is equal to this. Therefore, what do we have here? 5 sin 2x dx is equal to dt. I already have sin 2x dx here. So, sin 2x dx will be dt by 5. So, we can rewrite this integral. Therefore, the integral becomes 1 by 5 into integral of dt by t. So, that makes it 1 by 5 log mod t. That is, what is t by the way? 4 cos square x plus 9 sin square x. So, that we add an integration constant. So, it is clearly the option 3 is the right answer. Answer is in the option 3. Let us move on to the question number 16. Let f of x be integral x square by 1 plus x square into 1 plus root over 1 plus x square dx, and f of 0 is equal to 0, then f of 1 is equal to, first option log of 1 plus root 2, second option log of 1 plus root 2 plus pi by 4, third option log of 1 plus root 2 minus pi by 4, and fourth option log of root 2 minus 1. We have f of x to be integral of x square by 1 plus x square into 1 plus root over 1 plus x square dx. We observe that there is more than one term here with 1 plus x square, and by putting x equal to tan theta, it appears that we shall be able to handle this integral. So, let us see how it goes. What is dx? Secant square theta d theta, and the secant square theta is nothing but 1 plus x square. So, I will write this as 1 plus x square d theta. Dx is this. So, dx by 1 plus x square is equal to d theta. So, this dx by 1 plus x square that you have can be replaced with d theta. So, what is our f of theta now actually? It has been converted into function of theta. So, what does it become? Integral tan square theta, and what about this dx by 1 plus x square, we have already converted that into d theta divided by 1 plus secant theta. Now this secant tan square theta we can write it as secant square theta minus 1, and in the denominator we have secant theta plus 1 d theta. So now it is like secant square theta minus 1 divided by secant theta plus 1 will be secant theta minus 1. So integral of secant theta minus 1 d theta. So that makes it log mod secant theta plus tan theta and minus integral of 1 is theta plus c. Now let us get back to f of x. F of x is equal to, what is this? Secant theta we can write as root over 1 plus x square plus x minus tan inverse x, theta is tan inverse x plus c. Now since we are given f of 0, given f of 0 to be 0, we are given f of 0 to be 0. So this, when I put x equal to 0, this part becomes 0, this part also becomes 0. So c has to be 0, therefore c has to be 0. Hence we have f of x to be, therefore f of x is log of x plus root over 1 plus x square minus tan inverse x, that instead of c, what did we get c to be? 0. So we have this thing. Now clearly f of 1 from here is, I put x equal to 1, so log of 1 plus root 2 minus tan inverse of 1 is pi by 4, so pi by 4. So clearly it is seen in the option 3. So option 3 is the right answer. Let us move to the question number 17. Integral of x cos x into log x minus sin x divided by x into log x whole square dx. The options are, first option is sin x by log x plus c, second option log x plus sin x plus c, third option log x sin x plus c, and fourth option cos x by log x plus c. Now we will go by the options actually, it is simple because you see it appears to be the derivative of d by dx of sin x by log x. Let us consider this. It is clearly log x whole square, log x into the derivative of sin x, that is cos x, minus sin x into the derivative of log x, that is 1 by x. That is d by dx of u by v is v du by dx minus u dv by dx by v square. So going by this, it is clear from here, that is it is x log x into cos x minus sin x by x into log x square. So this is the derivative of sin x by log x. Hence the integral of, this is actually, the integral turns out to be differential of sin x by log x. Therefore it should be sin x by log x plus c. After all, indefinite integral is nothing but the antiderivative, so we get sin x by log x plus c, and that is clearly seen in the option 1. So option 1 is the right answer. So let us move to the question number 18. Integral of e power x by 2 secant x secant 2x into 1 plus 4 tan 2x dx is equal to, first option 4 e power x by 2 into secant 2x plus c, second option 2 into e power x by 2 secant 2x plus c, third option e power x by 2 into secant 2x plus c, and fourth option e power x by 2 by 2 into secant 2x plus c. Integral is e power x by 2 into secant 2x into 1 plus 4 tan 2x dx. If you observe, it appears to be close to this integral, e power x into f of x plus f dash of x. We know that this is the standard integral, that is e power x into f of x plus c. So secant 2x, when you multiply secant 2x to tan 2x is the derivative of secant 2x. So it appears to be close to it. So what we do is, but this is not in the standard format, so what we do is we put x by 2 as t, or x is equal to 2t. So dx will become 2 dt. So this dx part can be replaced with 2 dt. What about this? This will become e power t, secant 2x will become 4t, so it's secant 4t into 1 plus 4 tan 4t dt. Now dx was 2 dt, so we have a 2, I write it here. Now this is equal to 2 times of e power t into secant 4t, I will take it inside, multiply it inside the bracket, secant 4t plus 4 secant 4t tan 4t. Now let's see if it is in this standard integral format. We have this function of t, and is this f dash of t? If this is f of t, this is f dash of t. Clearly, what's the derivative of secant 4t? It is 4 into secant 4t into tan 4t. So now it is in the form of e power t into f of t plus f dash of t. Hence, I can write it as simply e power t into f of t. So 2 into e power t into secant 4t plus c. But then what is 4t? That is 2x. So that is 2 into t is equal to x by 2. So x by 2. Secant 4t will mean 4t is 2x actually. So secant 2x plus c. So answer is option 2. So let's move on to the question number 19. Integral of secant inverse of 1 by 1 minus 2x square dx. The options are, first option 2 times of x sin inverse x plus root over 1 minus x square. Second option x sin inverse x plus root 1 minus x square plus c. And third option 2 times of x sin inverse x minus of root over 1 minus x square plus c. Fourth option 2 times of x cos inverse x minus of root over 1 minus x square plus c. If you see, in most of the options there is a sin inverse x term. In fact, 3 of the options we have sin inverse x term. How about putting x equal to sin theta? Let's put x equal to sin theta and c. So clearly 1 minus 2x square will become 1 minus 2 sin square theta, and that is cos 2 theta we know. And here again dx is equal to cos theta d theta. Now this integral will now turn out to be secant inverse of 1 by cos 2 theta. And what about dx? Cos theta d theta. Dx has been replaced. What is this? Secant inverse of secant 2 theta, that is 2 theta. So 2 theta cos theta d theta. Now we can take this as the first function, this as the second function, and go about integrating. What is integral of u into v? U into, we recall the formula, integral of uv dx is u into integral v dx minus u dash, that is the derivative of u, into this integral whatever you got here, again copy it, that multiplied with dx. Now this again is a product of two functions. Again we will have to apply this rule until this gets simplified. We generally take that function which on differentiation becomes simplified as the function u. So that is the first function. On differentiation theta will become 1. So we will take that as the first function. So 2 into, now theta times of sin theta. What is the integral of cos theta? Sin theta minus of, now the derivative of theta is 1 with respect to theta, that is 1. So now we have just sin theta plus c. but that is 2 into, what is theta? Get back. Theta is nothing but sine inverse x. Sine theta is x, so 2x sine inverse x, minus of integral of sine theta is minus cos theta, therefore minus of minus will make it plus cos theta, and cos theta is, we get back, cos theta is root 1 minus x square. So we will write this, instead of cos theta I am going to write it as root 1 minus x square plus c. So we have here x sine inverse x, 2 times of x sine inverse x, there is a 2 common throughout. So 2 times of x sine inverse x, this, it is not, it is root over 1 minus x square here plus c. Answer is option 1. Let us move on to the next question, question number 20. Integral of ax square minus b by x into root over c square x square minus ax square plus b the whole square dx. The options are, first option sine inverse of ax plus b by x plus c by c plus k. Second option sine inverse of ax square plus b by x square plus divided by c plus k. And third option cos inverse of ax square plus b by x square upon c plus k. Fourth option cos inverse of ax square minus bx square upon c plus k. Now all the options are either involving sine inverse of some function or cos inverse of some function. Now we know that the derivative of sine inverse of x is root 1 minus x square, derivative of cos inverse of x is minus of root 1 by 1 minus x square. So derivative of sine inverse x is 1 by root 1 minus x square, derivative of cos inverse x is minus 1 by root 1 minus x square. So can we get it into that format? So let us see. What we do is, I will take an x square common in this, inside this square root. So we will pull out an x square. When it comes out to be root x here. So x into denominator c square minus, but I will have to multiply and divide by x square here. So x square, and when I take it inside it will be x. So c square minus, I will take a by x, ax plus b by x whole square. And now we have ax square minus b dx. It is almost clear now. Now I take this x square and divide it with the numerator here. So what do we have? We get a minus b by x square. So ax square minus b divided by x square. This portion I am rewriting like this. And we have in the denominator c square minus of ax plus b by x the whole square dx. Now it is clear now from here, if I put ax plus b by x as some t. Now this is in the form of root over c square minus t square, and we have in the numerator, what is this? Let us differentiate. A minus b by x square dx will be dt. So this a minus b by x square dx will be dt. So we have therefore dt by root over c square minus t square. Now this is a standard integral, sine inverse of t by c. This is sine inverse of t by c. So therefore what do we have here? Sine inverse of, what is t? Ax plus b by x, the whole thing divided by c, and you should have a integration constant, and that is clearly that. Let us not use the c, we will use some k. K is an integration constant. So clearly we have it in the option 1 is right answer. Let us move to the question number 21. If integral of 1 upon root over 2ax minus x square dx is equal to f composition g of x plus c, then f of x is equal to sine inverse x, g of x is equal to x plus a by a, that is the first option. Second option, f of x is equal to sin inverse x, g of x is equal to x minus a by a. Third option, f of x is equal to cos inverse x, g of x is equal to x minus a by a. And fourth option, f of x is equal to tan inverse x and g of x is equal to x minus a by a. Let's look at this integral, 1 by root over 2ax minus x square dx. Again, it appears to be, we have to convert this into the integral of the form 1 by root over a square minus x square type. So, you observe that 2ax minus x square, you can rewrite this as a square minus of x minus a whole square. So, now the integral turns out to be, what I do is I put x minus a as t. So, there is no difference between dx and dt, a being a constant there. So, the integral transforms to dt by, what about this root over 2ax minus x square, that is a square minus t square. Now, it is in the standard form sin inverse of t by a. Of course, the integration constant. What is t? X minus a. So, it is clear that from here sin inverse is an outer function, the inner function is x minus a by a. So, if you call this as, this should have been g and this should have been f. So, g circle f of x is this. So, what is f? What is g of x? Clearly from here sin inverse of x. And what about f of x? X minus a by a. So, in fact, it is in the form of f composition g. So, f has to be this and g has to be this. So, he has given it in that manner. So, let us take it that way. F of x is sin inverse x and g of x is x minus a by a. So, that is clearly seen in the option 2. So, option 2 is the right answer. Let us move to the next question, question number 22. Integral of sin x by sin x minus cos x dx. First option, half of x minus log of mod of sin x minus cos x plus c. Second option, half of x minus log of mod of sin x plus cos x plus c. Third option, half of x plus log of mod of sin x minus cos x plus c. And fourth option, half of log of mod of sin x minus cos x plus c. Let us see how it goes here. Sin x by sin x minus cos x. Generally, when we have a rational function of sin x and cos x, that is some f of sin x comma cos x divided by some q of g of sin x comma cos x, we go for a universal substitution tan x by 2 is equal to t. But then none of the options are involving tan x by 2. So, let us not go for that substitution. We will directly try to bring this sin x minus cos x, log of sin x minus cos x is involved. So, maybe the derivative of sin x minus cos x has to appear in the numerator. So, what I do is this sin x which we have in the numerator, we will write this as sin x plus cos x, sin x plus cos x plus sin x minus cos x by 2, whole thing divided by 2. We will write like this. This sin x plus, so we will write the numerator is half of sin x plus cos x by sin x minus cos x. I am splitting the integral plus 1 dx, because this sin x minus cos x divided by sin x minus cos x. Now, it is clear that the derivative of sin x is cos x, derivative of cos x minus cos x is sin x. Now, it is in the form of f of x, f dash of x by f of x. What is the integral? Log mod. So, we are using the integral f dash of x by f of x is equal to log mod f of x. So, using this, the derivative of the denominator is the numerator here. So, it is clear that it is log mod sin x minus cos x and plus x plus C, and that is clearly seen in the option 3. So option 3 is the right answer. Okay, let's move to the next question, question number 23. I suffix m comma n is equal to the integral sin x to the power m into cos x to the power n dx. Then I phi 4 is equal to, first option, sin x to the power 4 into cos x to the power 5 by 9 plus 4 by 9 times of I suffix 3 comma 4. Second option, minus of sin x to the power 4 into cos x to the power 5 by 9 plus 4 by 9 into I 3 comma 4. And third option, I sin x power 4 into cos x power 5 by 9 minus of 4 by 9 into I 3 comma 4. And fourth option, minus of sin x to the power 4 into cos x to the power 5 by 9 minus 4 by 9 into I 3 comma 4. So in all the cases, it appears that we have to write I 5 comma 4 in terms of I 3 comma 4. So let's see, this is, we have to reduce this integral I m n sin x power m into cos x power n dx. If you observe, we had to write I 5 comma 4. What will be I 5 comma 4? Sin x raised to the power 5 into cos x raised to the power 4. We had to reduce this into I 3 4. That means we'll go for this as the first function. We'll go for this as the first function, and this is the second function. Now let us consider this I 5 comma 4. This is sin x power 5 into cos x power 4 dx. This I can write it as sin x power 4 into, one sin x I will club with this cos x power 4. So that this turns into the form of f of x raised to the power 4 into f dash of x, almost that, to dx. So now this can be taken as the first function and this can be taken as second function. So this is almost readily integrable. So what we will do is, this is sin x power 4 into, what is the integral of this thing? Integral of this will be cos x raised to the power 5 by 5 with a minus sign, because derivative of cos x is minus sin x, so I don't have a minus. So I'll have to compensate by writing it here, minus of, now the derivative of first function, that is 4 sin cube x into cos x into, now this whatever we got here, we are going to copy it there, minus cos x raised to the power 5 by 5 dx. Now this turns out to be minus of sin x raised to the power 4 into cos x raised to the power 5 by 5. This minus of minus will make it plus here, and we have here plus 4 by 5 into integral of sin cube x into this cos power 6x. So what I do is, I will take out a cos x from here and write this as cos square x into sin cos power 4. So that we can write this cos square x as 1 minus sin square x again. So we then get this as it is, do. Now let's consider this part. Let's rewrite it here. This integral, I am going to rewrite it here. What do we have here? Sin cube x. I am taking it inside the bracket, sin cube x minus sin power 5x into cos x power 4 dx. So now this is sin cube x into cos power 4x is I 3 comma 4, because m is 3 and n is 4 there, minus, what about here? This is I phi 4. Okay, so what do we have now? I54 is equal to minus of sin x raised to the power 4 into cos x raised to the power 5 divided by 5 plus 4 by 5 into I34 minus I54. This I54 I'll club it here. So I'll get 1 plus 4 by 5, that is 9 by 5 into I54 is equal to minus of sin x power 4 into cos x power 5 by 5 into 4 by 5 times of I34. Now just cross multiply with this. This 9 by 5, I take it the other side. So we get I54 is equal to a minus of 9 into 5 will cancel, becomes 5 by 9. So that 5 will cancel there. I get a 9 in the denominator, minus of sin x power 4 into cos x raised to the power 5 plus 4 by 9 into I34. Of course, we need to add a constant, integration constant. So we have here this thing, I54 is this. So that's clearly seen in the option 2. Let's go back once more. What did we do? We wanted to write it in the form of u into v integral. So the second function has to be directly integrable. I took a factor of sin x from here, clubbed it with this cos x power 4, and we have this first function into second function. Now this is readily integrable. The integral of that is minus cos x power 5 by 5, and we have all this. Let's move to the next question, question number 24. If in is equal to integral of tan x raised to the power n dx, then I0 plus I1 plus 2 times of I2 plus I3 plus so on up to I8 plus I9 plus I10 is equal to, the options are, first option tan x by 1 plus tan square x by 2 plus tan cube x by 3 so on up to tan x power 9 by 9. Second option minus of tan x by 1 plus tan square x by 2 plus so on up to tan x power 9 by 9. Third option cot x by 1 plus cot square x by 2 plus so on cot x power 9 by 9. Fourth option minus of cot x by 1 plus cot square x by 2 so on up to cot x power 9 by 9. Now what is In? We are given In to be equal to integral of tan x power n dx. Now this we can rewrite this integral of tan x power n as tan x power n minus 2 into tan square x. Tan square x, I am going to write it as secant square x minus 1. Now split this integral, it turns out into the form of tan x power n minus 2 into secant square x minus tan x power n minus 2 dx. Now this is in the form of f of x raised to the power n minus 2 into f dash of x dx. So now this turns out to be tan x raised to the power n minus 2 plus 1, that is n minus 1 by n minus 1 minus, that is In minus 2. So In is equal to In minus 2, this minus In minus 2. So In plus In minus 2 is equal to tan x raised to the power n minus 1 by n minus 1 is what we have. Now what we want is I0 plus I1 so on and so forth. So what if I put n equal to 2? Put n equal to 2. We get I2 plus I0 to be equal to tan x by 1. Put n equal to 3. I3 by I1 will be equal to tan square x by 2. Put n equal to 4. I4 by I2 will be equal to tan cube x by 3. Keep on going like this, put n equal to 10. Then we get I10 plus I8 is equal to tan x power 9 by 9. What about the previous term? We get I9 plus I7 is equal to tan x power 8 by 8. Add up all this. By adding up all these, we observe that I0 and I1 appear only once, and of course I9 and I10 also appear once. Rest all the terms are repeated because I2 gets repeated here. I3 will get repeated somewhere, I5 plus I3. I3 will get repeated with I5 plus I3. I4 will be repeated again I4, I6 plus I4. So all these terms I2, I3 so on up to I8 are repeated twice when you add up all this. I0 and I1, I9 and I10, they appear only once. These two sets appear only once. So when you add up all this, what are we getting? Tan x by 1 plus tan square x by 2 plus tan cube x by 3 so on up to tan x power 9 by 9, and that is clearly seen in the option 1. So answer is option 1. So the key formula is that we have to remember this: whenever we have yn to be integral of tan x power n dx, the reduction formula, this is in plus in minus 2 is equal to tan x raised to the power n minus 1 by n minus 1. Let's move to the next question, number 25. Integral of sigma r ranging from 0 to infinity x power r into 2 power r divided by r factorial dx. Options are: first option e power x plus c, second option e power 2x by 2 plus c, third option 2 by 2x minus 1 plus c, fourth option 2 into e power 2x plus c. Now we know that sigma x power r by r factorial, r ranging from 0 to infinity, that is 1 plus x square by 2 factorial so on. This is the expansion of e power x. We know this. So instead of x, we have 2x, that's all. This x power r into 2 power r, I can rewrite it as 2x power r. So now the integral is simply e power of 2x dx, and that is clearly e power 2x by 2 plus c. Very clearly in the option 2, answer is option 2. Let's move on to the next question, question number 26. Integral of 1 upon cos x power 4 into sin square x dx is equal to, first option, half of tan cube x plus tan x minus cot x plus c, second option 1/3 of tan cube x plus 2 tan x plus cot x plus c, and third option 1/3 of tan cube x plus 2 tan x minus cot x plus c, and fourth option 1/3 of tan cube x minus tan x minus cot x plus c. So the terms appear to be in terms of tan x, so maybe some tan x equal to t has to be made as a substitution. So let's see whether that is apparent. Now what I do is, this cos power 4x, will write this as 1 by 1 cos square x, 1 by cos square x. This is secant square x, and this sin square x cos square x, we can write it in terms of sin square 2x by 4. So we'll write this as 4 into, and multiply and divide by 4. This becomes sin square 2x in the denominator, and we have secant square x dx in the numerator. Put tan x as t. So now the integral becomes 4 into secant square x dx is dt divided by, what do we know, sin 2x is equal to tan x by 1 plus tan square x, we know this. So making use of that formula, that turns out to be 2t by 1 plus t square the whole square. So now it's clear that it's in the form of that 4 and this 1 by 4 will cancel, and then we have 1 plus t square the whole square by t square, integral of that. And just open it up, that comes out to be 1 by t square plus t power 4 by t square, that makes it t power 4 by t square is t square, and what do we have? 2t square by t square, so 2 dt plus c. And that's clear. Now, what is the integral of t square? T cube by 3. What is t? Tan x. So, it comes out to be 1/3 of tan cube x. And what is the integral of 1 by t square? That's clearly minus 1 by t. So, the derivative of minus 1 by t is 1 by t square. So, minus 1 by t means minus cot x. And then the integral of 2 is 2t, that is 2 tan x. That plus c. That's clearly seen in the option 3. All these terms are seen clearly in the option 3. So, answer is 3, third option. Let's move to the next question, question number 27. Let f of x be a function such that f of 0 is equal to f dash of 0 and that's equal to 0, and f double dash of x is equal to secant x power 4 plus 4, then f of x is equal to, first option, log sin x plus tan cube x by 3 plus bx, and second option, 2 by 3 into log secant x plus 1/6 of tan square x plus 2x square. Third option, log cos x plus 1/6 of cos square x plus x square by 5. Fourth option, log secant x plus 1/6 of sin cube x plus x square. Let's see how this can be done. We are given f double dash of x to be secant x power 4 plus 4. So, we will integrate both sides, integrating both sides. What do we get on the left hand side? We get f dash of x. And what is the integral of secant power 4x? This will write it as secant square x into 1 plus tan square x. And that this integral of 4 is of course 4x. We should allow a constant c, integration constant c. But then this we can write it as secant square x plus, split it, tan square x into secant square x dx plus 4x. That c has to be 0 because f dash of 0 is 0, will imply c to be 0. So, I will just forget about this c there, c 0, I will not carry that. Now, secant square x integral is tan x, and then this is now in the form of f of x square into f dash of x. So, tan square x into derivative of tan x. What is that? That makes it tan cube x by 3 plus 4x. Okay, that is f dash of x. But we wanted f of x. So, again I will have to integrate f of x, integrating again, f of x. What is the integral of tan x? Log mod secant x. Now, what about this integral? Integral of tan cube x by 3, we will take it up, plus 4x into x square by 2, that is 2x square, plus we should allow again x some constant k. But that would also become 0 since f of 0 is 0, will imply k to be 0. Therefore, you have f of x to be log mod secant x plus 1/3 of f of x is equal to log mod secant x plus 1/3 of integral of tan cube x plus 2x square. K we have found it to be 0, so we will just leave it. Now, we will calculate this integral of tan cube x separately. So, integral of tan cube x, what is that? Tan x into, I will write this as secant square x minus 1, because tan square x we can write it as secant square x minus 1 dx. Now, this is in the form of tan x into secant square x minus again tan x. Integral of tan x, separate it. What is this now? This is in the form of f of x into f dash of x. So, tan square x by 2 minus, what about the integral of this? Log mod secant x. So, we can substitute it there. So, finally, what do we have? F of x is equal to this log mod secant x. We have it twice into 1 minus 1 by 3, because you have a 1 by 3 multiplying here. So, there will be a 1 by 3 multiplying this. So, log mod secant x can be taken common, and we have here. So, 2 by 3 into log mod secant x plus 1 by 6 into tan square x plus 2x square is the final answer. That's seen clearly in the option 2. So, answer is second option. So, let us move to the question number 28. If integral of 1 by x power 3 by 4 into x power 1 by 4 plus 1 raised to the power 10 is equal to k times of 1 by x power 1 by 4 plus 1 raised to the power 9 plus c, k is equal to 4 by 9, k is equal to minus 9 by 4, k is equal to minus 4 by 9, and k is equal to 9 by 4. So, let us consider this integral 1 by x power 3 by 4 into 1 plus x power 1 by 4 raised to the power 10. What we do is we put 1 plus x power 1 by 4 as t. Then we get 1 by 4 into x power minus 3 by 4 dx is equal to dt. So, we do have this x1, this x power minus 3 by 4 dx is present here, that becomes 4 dt. So, dx by x power 3 by 4 is 4 dt. So, this dx by x power 3 by 4 I will replace it with 4 dt, and what do we have here? T power 10. So, now that makes it 4 into t power minus 10 integral of t power minus 10 dt, that is 4 into t power of minus 9 by minus 9 plus c. Let us get back to what is t. So, what do we have? Minus 4 by 9 into 1 by 1 plus x power 1 by 4 raised to the power 9 plus c. So, the right option is here we are comparing with what is k. K is equal to minus 4 by 9, and the option is, right option is in the answer 3, third option. Let us move on to the question number 29. The integral of sine cube x upon 1 plus cos square x into root over 1 plus cos square x plus cos power 4 x dx is first option secant inverse of secant x plus cos x plus c, second option secant inverse of secant x minus cos x plus c, third option secant inverse of secant x minus tan x plus c, fourth option secant inverse of secant x plus tan x plus c. Now, if you see in most of the options, you see the integrand, most of the terms are involving cos, and do I have a sin x dx in the numerator? Yes, I do. So, what do? I will separate out a sin x from here. Now, this becomes the derivative differential of cos x. So, it is apt to put cos x as t, cos x as t. So, then we are almost getting this to be minus sin x dx is equal to dt, or sin x dx can be replaced with minus dt now, and the sin square x, it is clearly 1 minus t square. So, 1 minus t square into minus dt, that makes it t square minus 1. So, we have t square minus 1, denominator t square plus 1 into 1 upon root over 1 plus t square plus t power 4. Now, as you can see here, we will divide the numerator and denominator by numerator and denominator by t square. So, if you do that, what does it come out to be? The numerator will come out to be 1 minus 1 by t square dt. Again, t square, when you are dividing, we will divide the first factor by t here in the denominator and the second factor by t, so that when I take it inside the square root, it becomes t square inside. So, that is what am I doing? I am dividing the numerator plainly by t square, and the denominator also by t square, but the t square we split it into two parts, t for the first factor, t for the second factor. But that second factor involves square root, so I take it inside the square root by making it t square. So, what do I have now? We then have t plus 1 by t into root over, now t square by t square, now t power 4 by t square, that makes it t square plus 1 by t square plus 1. Now, it is clearly that we can substitute, it appears that we can substitute, put t plus 1 by t as some u, put t plus 1 by t as u, then clearly 1 minus 1 by t square dt will become du. So, 1 minus 1 by t square dt, the numerator is du. Let us get back, let us come here. So, what do we have? This integral turns out to be du by, this is u into, this t plus 1 by t whole square is nothing but t square plus 1 by t square plus 2, so minus 1. So, u square minus 1. Now, this is the standard integral secant inverse of u plus c. But what is u? T plus 1 by t. What is t? Cos x. So, secant inverse of cos x plus 1 by cos x plus c. That makes it secant inverse of cos x plus secant x plus c. And that is clearly seen in the option 1. So, answer is option 1.